Hi and welcome back to Smart Bites. Today I'm actually going over derivatives. My previous video I solved the derivative using the definition of the derivatives. Well, here what I'm going to do is show you a shortcut, basically a technique. Once you learn this, I'm going to write it. It's going to look confusing, and it's really not. So just bear with me here. Suppose I have, or here, let's do this. For any real number n, if I take the derivative with respect to x, what I'm going to do is I'm going to bring down the n, and then we'll have x n minus 1. And actually, really, looking at it really doesn't look that bad, huh? But I'm going to make it look even nicer, because if I say I have a function, we can call it whatever we want. In this case, I'm going to call it y. If I have x to the, I don't care, 10. If I have x to the 10th power, what I'm going to do is I'm going to treat this like that n right here. This is n, and what I'm going to do is I'm going to bring it down. So y prime is equal to 10. We have x to the 9th. And that's our derivative. Now before, what we would have done is we would have used the difference quotient and taken the limit as h approaches 0, and it would have really come out to a whole lot of algebra and a lot of room for mistakes. So this is a really nice tool. It's so nice. And what we would do from there is if we wanted to find the slope, an equation to the slope of the tangent line, then all we would need is an x value, and we already have our original function, so we can plug in and get our y value. Actually, I'll show you that a little bit later, just to solidify it. Let's say I have y is equal to x to the negative 2/3. Okay, not a problem. We can do that, sure. Well, if this is n, we can say y prime is equal to negative 2/3, because remember I brought it to the front, and we can say x and then negative 2/3 minus 1, which is equal to negative 2/3 x minus 5/3. Because all we're doing is a little side work just to refresh you here if it's been a while. I'm going to go ahead and change this to the least common denominator, and then we have negative 5/3. And that's what I did here. Okay, let's see, what else? How about this? X to the, well, what if I just said, well, how about this? X cubed minus 3x minus 1. Okay, well, sure. Y prime is equal to, I'm going to treat this as n, and I'm going to write this as 3x, and then 3 minus 1 is 2, minus, and then here we have a rule that says if we basically have a constant, well, we just keep the constant there, we don't even worry about it. But we take the derivative of this, well, the derivative of this is 1 minus 1, right? Well, if this is 1 minus 1, this is actually a 0, which is just 1. So it would be negative 3 times 1 minus. And anytime you have a constant, you take the derivative of a constant, it's going to end up being 0. So minus 0. So just to simplify that, y prime is equal to 3x squared minus 3. And that's it. Let's see, what else? There's a lot of ways we can go with this. And once again, I'm going to show you, well, here we have y prime is equal to 3x squared minus 3. Actually, I'll save that for a little bit. One more. Let me do one more, and then I'll show you. Let's see. Let me look for one here in the book. Okay. What about this one? I'm sure your professor's he's gonna ask you, well, what's the derivative of this? Well, the derivative of this is, well, what is pi? Pi is 3.14, and it just keeps on going, right? It just goes, and it's really 3.14 to the 6th power at that. So, really, pi is actually a constant, isn't it? So if you take the derivative of a constant, it's just going to equal 0. Let's do this one. Okay, so you can see here, y prime is equal to, and what I'm going to have here is a constant. So I keep my constant there, and then I bring this 2 down, 4 times 2, x to the 2 minus 1, which is just 1, plus 1. Oh, I'm sorry, plus 1, plus 0. Okay, which is equal to 8x. So my slope is really depends on whatever my x value is. Now, I said here that y is equal to 4x squared plus 1. Okay, and y prime is equal to 8x. Well, what if I introduce, what if somebody told me, well, what is the slope of the line at 10? Well, okay, all I need is at x equals 10, well, I can say, well, y prime is equal to, or the slope of the line is equal to 8 times 10, which is equal to 80. It's a pretty big slope. Well, what if your professor says, well, what about the write an equation for the slope of the tangent line? Okay, not a problem. Well, then we just go back to our intermediate algebra, or our pre-algebra, and we say y minus y1 is equal to mx minus x1. And then what I can do is I can say, well, he'll say, okay, well, at a point, let's say at a point, I don't know, 1 comma 3. Doesn't really matter. So at a point 1 comma 3, well, if I plug in 1 here, you can see I'm actually going to get 4 plus 1, which is 5. So that's my first x, which will be right here. And then my first y will be 3. So this will be 3. So if I rewrite this, y minus 3 is equal to our slope. And actually, I haven't even computed the slope yet, right? Well, all I do is I take my first x value here, and I plug it in here. So as you can see, if I plug in a 1 where 8 is, or where x is, then I'll just have 8, right? So m is 8, and then you have x minus 5, right? So this is the equation to the slope of the tangent line. I'm going to put it in slope-intercept form. Most professors, I would say, or any professors that I've had, have wanted me to put it in slope-intercept form. So y is equal to 8x minus 40 plus 3, which is equal to 8x minus 37. And this right here would be the slope of the equation to the slope of a tangent line. So really all I need is an x value at any point in the line, and I'll have its slope. No, don't put prime. Don't listen to me right now. Okay, so I hope you learned something from that. I'll be doing some more